I would like to introduce Jeff Haas from Juniper. He flew all the way to the Netherlands specifically to tell us about why we are where we are today when it comes to BGP. I have looked at BGP specifications a few times myself, and there have been pieces and places where I figure, how did we end up with this? And Jeff will try to tell us today why things are the way they are. This is not a justification, he's not defending any of it, but at least we will become a little bit wiser. Jeff, thank you.
Thank you, Jo. And just very beginning, very few of the issues in BGP are my fault directly, so don't blame Messenger. Quick note, I realize I am in Amsterdam and that people here generally speak English better than most people in the United States. That said, if I'm speaking a little bit fast through this very dense presentation, please feel free to slow me down. So a few notes about me. I have actually had a small amount of operator experience. I worked for a small ISP in Michigan for 3 years, where I dealt with, a whole 10 megabits worth of traffic. I had Protean and Livingston routers. I had everything from helping grandma set up dial-up networking to working through BGP issues. And I carried a pager, and that pager sort of left me with a very strong sense of things have to work right, because otherwise you have problems and somebody is suffering and staying awake in the middle of the night. I worked after that for a year at Merit working on the route servers for the old RSNG setup. And then after that I started working on BGP as a protocol engineer, originally part of Nextop, later on at Urban Networks, and these days 9 years at Juniper. So a portion of my work is working in the IETF on standards, including BGP. And at this point, the majority of the work that happens on the core pieces of BGP is inside of the IDR working group, which stands for Inter-Domain Routing, which is sort of interesting because the group originally was named BGP. It's sort of, how did we get there? Well, that's because back in the day they decided OSI was going to take over the world, and IDRP was their version of BGP, and we see exactly where that went. What's sort of ironic is that in the context of the military, a task force is intended to be a group of limited lifespan, and well, IETF's been going for 32 years. A little bit about me personally. My personal hobbies include doing medieval stuff, where I do sword fighting. I like to make beer. Sort of consequently, and the theme of the existing memes, I drink beer and I do BGP things. So, little history about where we got through from here. I'm not going to verbatim read these slides, but what's sort of interesting is I asked a couple of our grandfathers that are still around at Juniper about how do we get here. And Eric Rosen, among his other things, being one of the men that has largely invented all of the BGP-based VPN technology that we use today, was also the author of the original EGP specification, that EGP thing you see inside the origin of your BGP routes. Originally meant the EGP protocol. And there's a bunch of interesting details in here. I'm going to encourage you to look at this set of slides later on for some of the details. But the important thing was what we consider the internet today used to be a very small thing. There were 255 possible networks. Can you imagine something being that small these days? And the protocol that they actually used and how they numbered things was this crazy mapping scheme. And for those of you who've done work inside of NAT technologies, for CGNAT and such, you're seeing this type of thing pop up again. IP was sort of considered this strange layer 3.5 protocol. And back then, not everything spoke IP. What's sort of interesting is that the internet was effectively a hierarchical network. ARPANET was the root. And that the gateway-to-gateway protocol that was originally being used looked an awful lot like RIP, except for the fact that it didn't have all the things that we added to RIP later. Distances were largely there, but it didn't have things like split horizon, and therefore, we ended up counting to infinity. And it takes a very long time to count infinity when it was that big. So in Eric's context, what could go wrong? There's a bunch of highlighted things here for good reason, because these things are still problems for every protocol we do today, and not just BGP. Some implementations want to send state as fast as possible. Keep on, it's like, how fast can your BGP converge? Well, initial convergence, that's great, but the problem is sometimes being too fast causes you problems. some people decided, oh, this is too fast, we should slow down. Well, that meant that you had extremely long-lived routing loops. And second to last point, it's very hard to explain to people that sometimes clever implementation details have issues on a planetary basis. Last sentence, considering global impact. And this is really the big lesson that comes out of BGP over the years. So Eric has another couple of interesting points, which I think many people in this room would have sympathy with. And this is coming from a guy who these days only designs via PowerPoint and NROF. You don't want to be routing pure with the clueless. You want to be very careful with what you exchange with the clueless. We've just had a lot of presentations talking about routing security. There's no way to prevent any particular network from being run by clueless people. And getting agreement about things, including things like routing metrics, is damn near impossible. So as part of EGP, they came up with the idea of an autonomous system. And of course, we understand what that means today. Eric made the interesting observations that at the time that BGP was starting to be deployed, and EGP had this idea as well, is that AS path length as a metric was a really strange idea. But it worked out remarkably well for the timeline. And these days, it's still the only mechanism that we have that globally has real impact on your incoming traffic. The other interesting observation is that policy is something that came out of BGP, and that was a little bit of a weird thing at the time. At that time, people were mostly, this is a network, we turn on a protocol, and as a consequence of that, we have sufficient information to simply get things working. But policy ended up being important because BGP is about policy, policy is about money. The other interesting observation is that EGP worked on a simple datagram-based protocol, and BGP moved to TCP for interesting reasons. One of our colleagues, John Scudder, made some interesting observations about the fact that in EGP, it used UDP, and that he had to assist in a lot of late-night transitions from the old EGP protocol and other stuff to BGP3 because they started running into buffering problems due to fragmentation. You think, well, we support TCP these days, this is not a problem. Well, those of you monitoring your CERT email is noticing that TCP is having yet another fragmentation issue that's been announced, and router vendors are scrambling to deal with this. So old things still take care of themselves. So how do we get to BGP4? Only optimists expect to get it right the first time. I'm not going to spend a lot of time on this because everybody has seen the 2 NAPKIN proposal from Yakov. Yakov was sitting down at IETF and basically scribbled out the base idea for this. And that said, he didn't get it right. This is BGP 1. And it's worth pointing out that BGP does have a long history. The first version of it popped out in 1989. And then we effectively had a version every year for a couple of years where we got to the original BGP 4 around 1995. 1771's effectively was shipping in a lot of places. But that's not actually true. Let's talk about some of the things that we saw as part of this. One mildly amusing point, Jakob originally wrote his name as Jacob at that point. He got tired of people mispronouncing it, as I suspect a certain other gentleman in IETF land has noted. TCP was a core thing in terms of the initial implementation. Nobody else really did BGP over anything else, but there are options left there. And the reason why this is such a surprising fact is that at that time, TCP and IP stacks were not guaranteed to actually be present in all the boxes. Maximum update size was 1K. We had 16 bits worth of marker rather than our 16 bytes. And we actually had the open confirm as a message inside of the protocol. They eventually got rid of that. Hold time was in every single message, which is sort of weird when you think about it. What's probably the most surprising thing, if you're going back through history, BGP 1 was directional. So those of you who are looking at the sort of valley fee problems that we tend to talk about in terms of you're not a transit, you're not supposed to pass this stuff along. Well, originally BGP 1 was trying to solve part of that problem. What's sort of interesting is authentication was there day one. No extension possibility was put into the protocol. That said, authentication was almost never used. And it's still true today. We had fixed 4-byte NLRIs, and every one of them had a metric that got sent along with them. And one of the implementation details is every single system did the loop check for you. It wasn't done in ingress or ingress, it did it every single time. And the state machine had a transition table, and this was true all the way through the initial BGP4 specifications until we get to 4271. BGP2, again, deploying a new spec every single year. What does this mean? Among other things, nobody shipped BGP 1 and 2. Just they didn't bother with it. But the ideas continue to evolve as they're trying to solve the problems. And part of this is the first time that we actually got the taxonomies that we still use today, things like stub AS, transit, multi-homing, and the start of policy algebra, which looks remarkably similar to what eventually went at RIPE 181, and obviously from there into RPSL. It also mentions some of the criteria that we eventually used for route selection. So this showed up as early as BGP2, and eventually interactions with other protocols, since during the transition days, a big portion of what BGP was being used for was getting all these alien networks talking through a common bridging protocol. Message size grew up. The speculation about the 4K was that it happened to fit very nicely onto Token Ring, which of course was going to take over the world, and that the marker got a little bit bigger. Slight protocol changes, but one of the things that happened is we finally get, in BGP2, the common path attributes we tend to see today as an idea. What's a little weird here is that unreachability was a property of the message rather than of withdrawing routes. So you're expected to send out an update message that said, I'm withdrawing this, and then later you would send one with a new message, and this led to transient black holes when systems were running slow. BGP 3 is where we start getting the actual deployment. Slight protocol change to handle collisions so that we actually did that deterministically. Yakov had to take those lessons at a later point and applying them to the LDP protocol that he later invented. We eventually loosened the next hop to not be from the same AS, probably to enable things like route servers at the time. And then we added a little bit of advice about what to do about the fact that the protocol can get very noisy, and how does that impact things like route selection. What's sort of interesting was we had a RFC that was just before 1771 being the one that BGP was sort of shipping with, and this is where most of the work happened. We started stealing other features from IDRIP. We started talking about how does this thing interact with the IGP. So if you remember all those gross bits of Cisco configuration about IGP synchronization, well, it actually did that back then. Oh, that was such a horrible idea. BGP 4, we finally add support for classless routing. Everything BGP 3 and before was class full. So this is where we finally start getting real routing as we understand it today. We get support for aggregation, which at the time was a big deal. And the problem is we got aggregation, which is a pain in the ass. So we've started seeing both good and bad things. We also get this sort of injection of terminology from the OSI work that was happening for IDRIP. Addribs in, addribs out. Why didn't you pick something that was easier to talk about? But we did get rid of the idea of having to send separate messages for withdrawals, and the withdrawal field was introduced. We renamed things into what we call our meds today, and then we added the stuff necessary to do aggregation and dealing with IBGP's local pref. Connection collision, again, that was mostly dealing with what happens when two speakers are trying to come up at exactly the same time. And then we got this gigantic section on route selection, which I'm sure is on a lot of your exams and most of you hopefully forget about afterwards. This didn't last very long. What happened is we reshipped the thing as 1771. There's not a lot of changes beyond there. There's this strange tweaking where what was authentication, which nobody used, into optional parameters, and that got hijacked eventually into the extensibility mechanism. Eventually, we ended up with 4271, and what's sort of interesting is it took us 12 years after 1771 to ship before we actually got there. And for those of you who were on, dealing with actual BGP implementations, there were a ton of little details where things simply did not interoperate. I started my job, back around 2000, and part of my job was, taking care of this doesn't work with Cisco, this doesn't work with Juniper, these are all headaches, we need tens of knobs to ensure an interoperability, and how do we actually take care of these things? And I'd go to my boss, Sue Harris, which was one of the chairs for IDR, it's like, why is this stuff not right in the spec? It's like, well, you could actually send this off to the mailing list, which is how she sort of hijacked me into IETF. If you're ever curious about how did we get there, the draft that's referenced here has hundreds of pages of all of the micro issues that took us there. And part of that is we had to sort of deal with all of the other little extensions that I'll be talking about later, which you're familiar with, that dealt with interactions of those new extensions that weren't there at the time. Things like confederations, route reflection, route refresh, that impacts the finite state machine. Prepending was not even mentioned for several years, despite the fact that everybody was doing it. And just lots of clarifications. Probably the grossest thing that happened in there is the state machine went from something that was humanly readable to a text mess that still has errors in it today. What's a little bit interesting is there's some things that affected like the human anatomy in terms of useless organs. Atomic aggregate was a feature that had been added to the protocol originally as, for the BGP 3 to 4 transition to deal with the fact that somebody might deaggregate their prefixes. This makes sense when you're going from a classful network to a classless network, except for nobody ever did this. But this little vestige of protocol machinery in there made sure that we went through at least 5 or 6 different revisions trying to accommodate that. So BGP is surviving well and prospering in many cases because it's extensible. And stealing a phrase from English parable, the road to hell is usually paved with good intentions. Well, the road to BGP is paved with extensions. Path attributes, all the way back to BGP 2, we had the core things that we needed in order to allow us to carry new things. Everything that wasn't part of the core spec is optional, and you can have it as a clean TLV. So if you don't understand the thing, you're still capable of passing it on to somebody that might actually take benefit of it. And that was critical to actually allow for new extensions to be devised, deployed, and make BGP a richer thing. Despite the fact that this was actually defined in BGP 2, we didn't actually see this starting to get used until BGP 4. And one of the key properties of the path attributes is, are they transitive or intransitive? Transitivity says that pretty much, anything that isn't understood will still be passed along. We can mark it as partial in that case. But the problem is, even though it allows us to say for new things, I don't understand this, you can have it. Well, unfortunately, some things you don't understand, pass along to somebody who does understand, and they're like, why did you send me this complete trash? And we've seen multiple incidents over the years that cause global routing outages that cause problems. So good feature, yes, but unfortunately the source of bugs. And eventually, this killing the messenger behavior for a bad attribute that got past a certain point did eventually get us to the point where we could actually adopt a new error handling procedure, which is thankfully very well deployed at this point and keeps us from having the network crash when these new things happen. This is particularly a problem for a lot of VPN-related technologies, unfortunately, because as, for example, L3 VPN routes transition from being L3 VPN to normal routing, sometimes stuff that wasn't understood gets propagated along despite the fact it's effectively a VPN thing. Non-transitive, despite the fact that it's part of the core feature, it's mostly not used. It requires every single speaker that's along the path to make use of it. And as a consequence of this, it just doesn't get used very well. You see it for some core features like AIGP, but for the most part, it's not used. But what this is sort of pointing out is that things in BGP really are in desperate need of better scoping, control of how far they go. We also look at other extensibility mechanisms. As an example, the path attributes have a flags field. There's 4 bits left there. Ideally, we should be able to make use of them, do something interesting with them. Hey, we're doing this error handling procedure. Let's actually steal one of the bits to say that we're suppressing some of the attributes. Oh, we just knocked over a portion of the internet that was being too picky about a field that didn't matter. So what we see is that even though we leave space for things, sometimes implementations being too particular about things where they shouldn't be cause problems. If any of you want to do some entertaining experiments, send these things out and see what knocks over. So session and route scaling is obviously a thing that came up as an important thing very early in BGP's history. Confederations and route reflection, arguably, which one came first? You talk to different vendors, there's different cases driving them. I'm sure each of you can name a very popular old network that actually does support confederations. Originally, this idea was stolen from the IDRIP protocol. What's sort of interesting is this is a highlight of how process versus code sometimes gets a little bit out of skew. The original internet drafts had the code points, the magic numbers needed in the protocol to say that this is a confederation set or sequence reversed. And all the deployed code had the right magic numbers. So everybody that tried to implement it from scratch, from the document, got it wrong. Things fell over and went kaboom. And there's a bunch of other small details in there, like what do you do about your next hops? What do you do about local pref? What do you do about some of the behaviors with your AS path in terms of loop detection? These are all minor details when you think about them, but when you get them inconsistent in a network, you can have problems with deployment. Somewhat similarly, route reflection, different idea. Originally we were talking about could we use like something like route servers to do these things. Well, that didn't go anywhere. Instead, let's actually try to do something that doesn't require the edge speakers to be upgraded. So the whole idea with route reflection was supposed to be transparent. You didn't have to do anything, except for the fact that you're seeing that there's 3 different RFCs here. We originally started out with, here's route reflection, and then we find some cases where things don't quite match up and end up with inconsistent routing. And then do you do split horizon and suppress the stuff back to its originator? And things about what you do with the next hops, these weren't clear. And then we do it yet again, a 3rd RFC. And what we see is each of these RFCs start out with the idea of incrementally trying to be transparent. Don't require the edge to upgrade. And yet we still have impact on the core protocol. And of course, route servers are a popular thing these days. What's sort of interesting is they were originally a scaling mechanism for the original NSFnet, and they're back to being popular for various reasons. And I won't spend too much time here because you guys know that better than I do. Route flap damping is an interesting topic. Most of you who are old enough to remember the bad old days when damping was pervasive, you turn this thing on and all the noise from internet goes away. And about 20% of your reachability too. It was a nice idea, made people terrified to change their routing, except for the fact that any number of issues, BGP wedgies among them, would eventually cause too many routes to be sent over the course of global internet convergence. This is somewhere where we started seeing how does the internet actually behave in a highly meshed system. And it ended up being a bad idea, and eventually RIPE said, stop using the thing, it just doesn't work. We do actually have a new RFC out that says, here's ways to set the metrics high enough, see if it actually helps us. It's not well deployed as far as I know, but it's still an idea that's out there. What's sort of terrifying is that the number of prefixes that are corresponding to the real noise in the internet is a very small number. If you threw them away, you'd stop caring. Bigger problem in terms of scaling is you can't hold on to everything in some cases. The old days of running a Cisco 2514 and it's like, oh, I don't have enough memory in here. I have to throw everything else away. The only way to get back to your stuff was to flap your BGP session. Did not work for anybody. We added route refresh. It does the job. The gotcha is it's extremely noisy because you get back all of your routes, and one of the biggest things that's a huge CPU drain on a BGP speaker is processing that incoming routing feed. Ideally, we do better. We do actually have a new mechanism that is sort of like a very lightweight form of graceful restart that's starting to be deployed, and that does help a little bit. BGP is successful because not only is it extensible, but we've gotten to the point where we can actually carry something that isn't just IPv4. So V6 was obviously a big motivator for us. There was multiple proposals over the early history of V6 of how do we carry this in BGP, including a completely new protocol. Same thing for like carrying multicast state in BGP. No, they didn't get popular. We eventually figured out how to attack existing implementations. And the observation here is every time somebody tried to introduce a new protocol to split this stuff off, in most cases, it wasn't the vendors. It was the operational community saying, I don't want to run another protocol. Could you just stick it in here? So keep this point in mind as we talk about our problems later on. So ITF eventually said, let's actually do something. We need to actually carry this stuff. And so what do we actually do? Well, as I mentioned, your two choices: completely new protocol, chips in the night, or embrace and extend. And if that's intentional from the Microsoft end of things, because it's usually extended in an incompatible way. Thankfully, we got out of there relatively quickly, but it gets messy. And a lot of it, like I said, comes down to dealing with your existing install base. But another question is, at what point do we eventually end up at a BGP 5? The way we solve the problem is that that optional parameters field, which didn't really use anything, authentication never got deployed. We eventually decided that we're going to start carrying capabilities in there. And what's sort of irritating, and this is another one of the Haas standards that are very much, as the phrase goes, watching the sausage get made. The original feature was capability negotiation. I tell you what I'm going to do, I tell you what I'm going to do, and we try to actually arrive through bouncing the session a few times at what it's going to be. And they decided fairly early on, negotiating was actually a bad idea. They eventually went to capability advertisement. I tell you what I'm going to do, I tell you what you're going to do. We use the agreed upon set to do our work. But the problem is that thrashed enough in a negotiation that there's bugs across implementations to this day, dealing with things. So if you've ever seen sessions fail to come up after you've changed like an AFI-SAFI on something, well, that's partially where it's at. The other problem is, how do we actually carry the stuff around that isn't v4, doesn't fit into our existing NLRI fields? Those are meant for v4 only. So we were looking for a way to hack the stuff in, and we did it via throwing into a path attribute. So let's put it there, but remember we have to be careful about not letting these things go further than necessary. They still want to be optional transitive. We use capabilities to limit the dissemination. 2858 is where we eventually got there, although there's some weird stuff in there like SNMPA that nobody ended up really using. The problem is, once we did get v6 in there, people started arguing over what do your next hops look like. There was this big fetish inside IETF for a long time over every one of your next hops should be linked local, except for the fact that BGP, they may not be directly connected to each other. So spec-wise, in cases where the stuff's directly attached, you actually send both of them. Seems like a great idea, except for the fact that even though you carry both, in many cases, there are problems. There are some implementations that don't listen to the linked locals. I'm going to not put it in the slides, but wave the hands of one vendor who does such things. And as a consequence, you end up with interop problems. And of course, there's whispers of the future of things like MPLS, putting that stuff into the protocol. And it's too big to go into this presentation. One thing obviously of interest to a lot of this crowd is some amount of firewalling to deal with denial of service stuff. BGP flow spec is an example of the extensibility being a good win for us. So marking up routes is a popular topic for everybody in this room because this is probably where you spend the majority of your operational practices. BGP communities got specified in 1997 and 1998. Simple scoping things like no export, no advertise are heavily popular to try to control how far your routes go and therefore try to shape your incoming traffic. And then of course, the practice of sticking your AS number in there to allow you to provide arbitrary ways to signal things so that you can control things like I want you to update your prepending, your local pref, etc., became very popular. These things, despite the fact that there are common practices for any number of these things, there's no standardization to what a number means. For supporting VPNs primarily, there's an extended communities feature that got put together, 8 bytes wide. It has some level of structure in there, except for the fact that our friends originally from Cisco didn't get the structure stuff quite right, and it makes for hellish code. So unfortunately, it's not as clean as one would like, but it does the trick. So structure, but it's inconsistent. It looks formatted, but you can't quite trust it. And as a consequence, it gets used heavily for VPN features, but isn't very heavily used for anything but. Mostly because every time you specify a new one, the formatting has to be determined after the fact. But they have proven to be very flexible. What's unfortunately a problem is a lot of these things get used in the sort of magic community context. So like many of you may use the link bandwidth community to signal exactly how much capacity is available on a link to enable unequal load balancing. Well, the problem is what happens if you have more than one of these magic communities on your link? Not specified. They're not very good about that. What's sort of interesting is that these types of things eventually lead us to the idea of providing some amount of remote policy, control over don't send me stuff that I'm not interested in. Originally, we tried to do outbound route filters. Not a terribly popular feature, sort of buggy in a lot of cases, and the original spec before it hit RFC was a full refresh, which was a little overweight. RT constraint is very popular to this day for controlling VPN distribution, but again, not mostly for this crowd, but worth looking into because there's possibilities of it being used for non-VPN technologies as well. Large communities is near and dear to the hearts of some of the people in this room. It solved the problem that when you talk to protocol developers, they're looking at things, well, these things are just numbers. We think in terms of equivalence classes. And what's the problem here? Why can't you just simply stick this into an extended community and use 2 bytes worth of answer? Well, of course, the practice in a lot of ISPs is AS:AS actually has well-defined meaning for your policy. It's easy for users to remember, and you can't encode an AS these days in only 2 bytes. So after a lot of squirming around in IETF, we eventually end up with large communities, and that solves pretty much exactly the same use case. Let's see, yeah. There's been other work, which I'm one of the people that's worked on it, to try to actually put intent into the routes themselves. So can we actually avoid this giant mess of policy, to try to do things? I want you to prepend. I want you to block. I want you to no export. I want you to RTBF. Why should these things be different in every single vendor? Could we make it easier for the customer ISPs to do their job? So things like flexible communities and wide communities are 2 proposals that popped up over the years to try to do this sort of thing. They're always controversial. Let's not go over it here. Let's talk about it over beer. Now, markup is something that's just not done. We have an extra community, courtesy of our friends over at Cisco, because extended communities weren't wide enough, and this is where we're going to be spending a lot of our time in IETF, is just yet another markup. Transport security and resiliency. Some of you care about the transport security. A lot of you don't. BGP works over TCP. As I mentioned earlier in the presentation, it was an option, but it eventually became what was default. It's what everybody did. And the problem here is that even though it has proved to be an easy thing and it's made it easy to write implementations of the protocol, because you can open up a socket, start shoving PDUs down it, it means that core BGP developers, people working on scaled implementations, almost every single one end up being a low-level TCP expert because TCP is a pain in the ass. It causes problems. You get congested windows, you get CERT issues, you get window attacks, you get slow readers, and it causes all sorts of very interesting and hard to debug problems. And all you see at your end of the things is, hold time expired. What does that mean? Why did it expire? Interesting headache. Problem is, TCP never really had a built-in security mechanism. One of the things that happened very early in the days was attacks against the protocol itself. We needed some way to actually deal with it, specifically TCP reset attacks, and we ended up with TCP MD5, which is a complete hack. We generally don't see it as part of a suite. Linux eventually pulled in old patches on it, mostly to enable the protocol, but it's still a hack. At some point, we need something better. IETF has TCP/AO, but it's not deployed because nobody else besides routing people really need such things. You talk to the security people, they want us to use IPsec. Deep breath. How many of you really want IPsec in your network protecting your BGP? Graceful Restart was put in to try to deal with some of the resiliency problems. It allows you to bounce your session. Your routes get held on for a while. They come back, and resync. It's very heavyweight. It does rely on things, around you helping you. And it's popular as part of a standard IETF methodology of, get the surrounding systems to help. But a lot of people don't like relying on that. So unfortunately, one of the features that we tend to see is various vendor forms of nonstop routing, where effectively the router man-in-the-middles all its own traffic, and will use that to handle a switchover if one of the CPUs dies on the system. NSR makes software developers very, very angry because it causes all sorts of interesting headaches and to some extent makes for as many bugs sometimes as it's trying to prevent. Future, there's a lot of things that we have as options. Routing security has finally become a popular topic. We spent probably a quarter of our time, if not more, here today talking about it. Row validation is nicely starting to deploy and I think actually has good value. And, as Job has pointed out, I encourage every one of you to deploy that. Multiple vendors have support for it. Route leak prevention is something that you can't prevent with row validation. And this is still a controversial topic. There is work going on in IETF to try to look at this. All the way back to BGP 1, it was known to be a problem, so we're trying to deal with it. So that we have to figure out what to do in the protocol and then figure out mostly the operational glue to do with it, because that's where the real problem ends up being. Attribute scoping is a popular thing because we know this is where a lot of our security issues come from. We have features that are being developed for things like VPNs that you, as internet providers, just don't care about. Keep this crap out of my network. Why is it going here? And there's also things like automation infrastructure. Can we do things like make BGP auto-provision its endpoints? If you're doing something, for most of your CPE customers, you just want to plug in, you want it to just work. Could you make that part a little bit easier, not worry about IP addresses, et cetera? And in the context of things that are popular in IETF right now, routing protocols participating in data center fabrics, you want those things to be easy as well. So last couple of slides, lessons that we've learned about routing, specifically in BGP. So the good stuff, IETF mantra of rough consensus and running code, that worked great for BGP in the early days. Things happened fast. Protocol evolved very quickly. The problem was that, that only takes you so far. Eventually you get enough code, enough people trying to do things, enough edge cases that you have to start writing this stuff down. But iteration is good when you can actually do that. Having extensibility mechanisms put in up front is one of the things that makes the protocols have longer life. So we did that well, I think. Still don't need a BGP 5 at some point? We might. The ability to carry new things keeps BGP to be a very popular protocol. VPNs are a good example of that. The fact that you can get access to your BGP link state information for your entire IGP network. BGPLS is another example of a win. Technologies such as segment routing and such are enabled by these things. So this is, extensibility has actually done us good. Of course, the exact same argument made the opposite direction is a bad thing. BGP carrying everything in the kitchen sink too, just means that sometimes there's a lot of competing interests, not only in terms of the code, because the same code could be very, very stable if no new features went into it and you're only working on bugs. But vendors obviously have competing needs. We have people that are using things like VPNs. They want that functionality too. So it's been both a good and a bad thing. Carrying too much in the way of different address families can actually cause convergence issues. If you're running IPv4 and IPv6, well, the question is which one's more important? If v6 is actually more important for a subset of your customers and you converge v4 first, this becomes an issue. This has pushed things like potentially multi-session BGP, which moves the problem around a little bit, but doesn't necessarily solve it. The lack of scoping has led to all sorts of experiments or early deployed code, as the original authors for the large communities would know when they accidentally collided with somebody else that was squatting on code points. It causes damage. In some cases, it caused flapping sessions. Same thing for VPN features that aren't clean about their cleanup. Something that's transited to VPN, once it's entered the internet context, throw away all the control information. It doesn't help you and might actually hurt you downstream a little bit later. And one of my crusades in IETF is about code point management. It's a critical thing. If you don't do it right, you're going to run into problems. And we need better features to allow us to do experiments. And sort of the last thing, which is the good, the bad, and the ugly. BGP is a deployed protocol. All of you are like, please don't break my networks with your new stuff. Just leave it alone. but we can't quite go there. Incremental deployment of new features is tricky, and it's probably the most important thing about BGP to preserve. So as an example, some router vendors have features to filter new path attributes. You can just throw them away, but what you've just done is you've broken incremental deployment of something new on the internet, which you yourself may want to later use. So one of the things that we need to do is have better communication between operators who actually operate networks and vendors who are writing code, because operators don't necessarily understand writing code, and obviously vendors don't always understand operations. So thank you for your time.
The rest of the evening, Jeff is available to help configure your networks. Any questions for Jeff on this magnificent topic?
Hello, Jan-Georges. Can you go one slide back, please? The last two sentences, very true. Most protocol developers don't operate networks. Most operators don't understand protocol development. Yes. How can we fix that?
Why am I here?
Bingo.
Great, thank you.